Hi, my dear students. In today's class, I would like to give the information about method of sections. Earlier, we know about method of joints. Now we will know method of sections, right? So I will maximize. So, so this is the Truss. Earlier, we completed some problems related to calculation of forces in all the members of the truss, just like whatever you are seeing in the figure. In this, it is given find the forces in all the members. Okay. When all the members, you don't have any option. Otherwise, only to take method of joints. Okay. So you need to find the reactions initially. Reaction at A, reaction at B. After that, you need to consider what is the force in AB, force in AE, force in BE, force in BC, force in CE, force in DE, and force in CD. Every force you need to find. Okay. But if your condition is diluted, that means only few members forces are required for you. Okay. Only few members. I don't want to have the forces in all the members. Suppose I want to find the forces in CD, right? So suppose I need only in CD, right? That means I need FCD is required and FDE is required. Only these two. Okay. Otherwise, I will ask you only FBC. What is FBC? Okay. Right. So when very few members or forces are required for you, then you are going to find the second method of sections. And this method is also called method of moments, because we are going to find all the forces mainly by taking the moments from different points, right? Now, how to do this method of sections and method of moments, I will show you by taking one diagram. Okay. Right. I will take this into okay. I will take this figure to another screen, the Paint 3D. Here I will show you how to do these sections. Okay. So section means cutting. Okay. So I think everybody know it. Section means one cutting. Okay. Now you need to cut your truss into two parts, right? The first condition is you need to cut the truss into two parts. How to cut it? Now we'll take it. Okay. Now you are seeing a truss. A is a hinge joint. D is a roller joint. Okay. Support. Okay. Hinge support or roller support. Right. And F, E, these two are loaded with 16 kilonewton, 10 kilonewton, and 12 kilonewton. And B is a joint. C is a joint. Okay. Now suppose you are asking about the forces in the members FE. Okay. So we are considering initially FE, FC, and BC. Suppose these three are required for you. Okay, I will cancel it. Okay. These three are required for you. Now, where I need to draw the section. The section you need to select in such a way that what are the force members are there. So you need to pass through them. Suppose I need FE, FC, and BC. So I need to take a section passing through these three. That means this section is dividing this particular truss into two parts, right? How it is cutting? So I am erasing the truss because this is cutting. Okay. So this is cutting my truss into two parts. Clear? So this particular section, this is the section, is cutting my truss into two parts, clearly separated two parts. Okay. Now you identify FE. It is cut by the section, right? Whenever this is cut, there is a force FE. F, suppose I am saying F1. Okay. Let us take F1, F2, F3, right? Or otherwise F of EF. This is our notation. And it is also F, EF. So part of the force is transferred to the left section, part of the force transformed to right hand truss. Okay. Now you are having two trusses, left side truss, right side truss, right? Now you look after the force FC. So F, CF, and this will be F, CF. What about this BC? This is FBC and this is FBC, right? Got it. Now, so clearly the section should divide the truss into clear cut left portion, right portion with individual force division also, right? So I divided EF force into two parts, one to the left section, one to the right section. Got it? Okay. So here you can see this is the left and this is the right portion. This is the left portion and this is the right portion. And FBC, left portion and right portion. Now for your analysis, for your calculation, you can take either left portion or the right portion according to your convenience, right? Now, how to identify FEF, FCF, FBC and other forces, right? So what are the different steps? The steps are, first thing, okay, so I will save this, save in paint video. Okay, now we are opening another thing. The first step is what you need to do. Find the reactions at supports. So the first step in doing the problem is find the support reactions. This is already known to you. This is by the method of moments. So taking the moments from the one support, other support reaction will come. So sigma fx equal to 0, sigma fi equal to 0, and sigma m is equal to 0. By means of that, you are able to find support reactions. This is same as in the earlier method. Now the next thing is select the section by the rules. So what are the rules? I will tell you. Third one, take moments from different points. Take moments from different points to find member forces. Okay. So wherever you find, you need to take the moment from the requisite points and how to select the different points. So this is two things are there. Select the section by means of the rules and points. Selection of the points. Once you are identifying the section by the rules, after that, different points. That means how to select the point. How to select the point means we need to select the point such that we are having only one unknown. That means if you are selecting a particular point, many forces must pass through that particular point. Suppose I am having three unknowns. Okay, three unknowns. Right. Suppose we are seeing the earlier one. Is it is? Oh my God. Okay, right. So in the earlier case, it is one force like this, one force like this, and other force like this, some other force like this. Okay. So we need to select a particular point so that many of the forces must be passing through that point. So automatically their movement will become zero. Right. Finally, I need to left with one unknown. Okay. And you should not select supports until unless at least one of the unknown is found. Okay. Okay. This particular condition it can be applied at the last, no problem at all. Okay. Forget about this one. This is not very critical. So select the different points to find the member forces. After doing first force, second force, you are going to identify the forces and finally you will get a values finally from the supports. No problem. Okay. Now we can see how to select. What are the selection rules? So how to select the section? See, the first rule is the section should pass through, I will mention this. The section should pass through the members only, not through the joints. Okay. So section has to cut the members. It should not pass through any joint. That is the condition. Okay. And a section should divide the truss into two clearly separate and unconnected portions. Earlier you might have seen. See, I will open the earlier cutting. Now it is loading. What we had done earlier. See, it is cutting the truss into two clearly separated two halves, right? And it is passing to the members EF, CF, and BC clearly, okay? And it is not passing through any point or any joint. Understood? Now, what is the third one? A section should cut only three members. Since why? Because we are having three unknowns and we are having three equations of equilibrium. One is sigma fx0, sigma fy0, and sigma moment about any point is 0, right? But in special cases, more than three members may be cut by a section. So there we are having more equations and somewhat the problem will become little bit more computed. That is only in special cases. Okay. Now, the fourth condition is when using the moment equation, it is very critical, right? Critical means not difficult. Critical means important. When using the moment equation, the moment can be taken about any convenient point. Remember this point? Any convenient point which may or may not lie on the section under consideration. Okay, right? That means, suppose I am selecting the right hand section, right? Is it okay? Now I am selecting right hand section. So the moments can be taken. So I am modifying the left section. Just I am keeping only the joints. Joint means a point. Okay. Now you are looking, see, in the diagram, you are having different points. What are the different points? I am marking with the green color. Oh, I am marking now. So moments can be taken from the point D. Moments can be taken from point E. Moments can be taken from point C. That is confined to the right hand section. Okay. Now, any convenient point which may not lie in the diagram. So on the right hand side, you don't have the points F, B, and A, but you can take the moments from the point F also, from B also, and A also. But while taking the moments from that particular A, F, and B, just like what I have shown, they need to be completely isolated from the forces. So while taking the moments to the right hand portion from the left side point, don't consider any force, including the reaction A also, right? You forget about everything. So A is isolated. So better I need to delete the support also. Okay. So why we need to select A or B or F? It is only your convenience. Okay. Suppose I need to find FEF, FCF, and FBC, right? So it is better for me to take the moments from point F. Why it is so? I told you very clearly. You need to select the point such that many forces must pass through that, so that you are left with only one unknown. Now you look at the point F. EF is passing through F, so its moment will become 0. FCF, it is also passing through F, so moment is 0. I am having left with FBC, it is not passing. So from F, if I take the moment, FBC multiplied with perpendicular distance. So from this, it will become clockwise moment. So there will be another force. Here it will be RD will be there, reaction at the D, right? So how many forces are left for me to take the moments? One is FBC, second one is RD, third one is 12 kilonewton. So 12 kilonewton into the distance. It is given 5 meters, and RD into 10 meters, and FBC into this vertical distance. Already it is given 4 meters. So I am left with only one unknown, FBC. So very easy to calculate for me. Suppose clockwise moments 12 into 5 plus FBC into 4 is equal to anti-clockwise RD multiplied by 10, right? So I told you very clearly, initially you need to find reactions at the support. So RD will be known to you. Now you are having only unknown FBC. So from this I can find FBC. Okay. So like this, each and every point to be selected carefully, right? So any convenient point which may or may not lie on the section under consideration, right? So these tactics will come if you complete more number of problems. Okay. So with this, I will conclude this lesson. We'll do more problems in the next class. Thank you very much. If you like this video, please like, share, and subscribe. Thank you.